Okay, here's warm up 11.3. We're going to find the area of this figure. Okay, so we've got this is going to end up being a rectangle, and I've got a right triangle as well. Since this angle is 90 degrees, that means this one is 2, right? And then if you look at this figure, the remaining angle would have to be 90 degrees. You could do n minus 2 times 180, or you could use the consecutive interior angles since I've got those parallel lines, but it's a rectangle, okay? And then, so there's some things that I know about rectangles. One of the things that I know is that the opposite sides are congruent. So if the left side is 7, that means the right side is 7 too. Those are both going to be 7. The top and bottom are both going to be 12. It turns out not going to really need the 12 on the bottom there, okay? So finding the area of the rectangle, I'm just going to do base times height. So I've got 12 times 7, or 7 times 12, however you want to think of it, and that's going to give me 84. Okay, so this piece here has an area of 84, but I still need to find the area of the triangle. And here's where this 7 is going to come in handy. So looking at this triangle, I've got 30 degrees, 90 degrees. That means this has to be 60 degrees. So this is a 30, 60, 90, okay? So we could actually use, so I'm going to need to find the area of this triangle. So my area is going to equal 1/2 base times height. The base and the height have to be perpendicular to each other, so I'm going to want to use these two sides as my base and height. So I've already got the 7, but I don't have the bottom of that triangle. And there's a couple of different ways you could get it. One way is to use SOHCAHTOA. I could use SOHCAHTOA because I've got a right triangle. I could also use the special right triangle relationships. So the 30-degree angle, this isn't to scale, but the 30-degree angle would have to be across from the smallest side. So this is going to be my short leg here. Okay, so I'll put SL for short leg. And across from the 60 degrees, this would be my long leg. So going from short leg to long leg on a 30, 60, 90, since it's getting bigger, even though it doesn't look like it in the diagram, it's getting bigger going short leg to long leg. I'm going to be multiplying, and here I'd multiply by the square root of 3. So this bottom side would be 7 root 3. If you use SOHCAHTOA, you could get a decimal approximation of 7 root 3, and that would work fine too. Okay. Now I've got a base and a height pair I can use for the area of the triangle. So I'll use 7 root 3 as my base and 7 as my height. So let's see, I'm going to have 1/2 of 49 root 3, and that's going to give me, I'm going to make a decimal approximation of this. So, you know, you could say that this is 24.5 because that's half of 49 root 3, but I'm going to make a decimal approximation of this as well. So 24.5 times the square root of 3 is going to give me about 42.44. Okay, and so that's the area of the triangle piece. So here, I'll put this in here. Okay, and now the total area, I'm just going to add those two bits together. Okay, and this is approximate because that decimal is rounded, and that's going to put me at about 126.44, and I want my units in my final answer here, so this would be square centimeters since those sides are in centimeters. And area is always square units. There we go. Okay. All right, there's number 1. Number 2, let's find the measure of arc XY. So arc XY is this piece of the crust of this pizza, and it has the same measure as the central angle that intercepts it. So this is going to be 45 degrees. Okay. The length, though, is different. I'm talking about the actual length of that piece of crust. If you straightened it out and measured it with a ruler, you could do that, right? And it would be a certain amount of centimeters since this radius is given in centimeters. So this pink piece of the crust is part of the circumference of the whole circle. So arc length, I always think of arc length that way, as part of the circumference. Okay, and you have to know the circumference formula. So the circumference formula for a circle is 2 pi r, or you could call it pi times diameter, but I've got a radius here, so I'll use that. Okay, so here the measure, the length of this arc, the part of the circle I'm talking about, it's 45 out of the total 360 degrees, and then I'm going to put the circumference in here. So 2 pi times 6. 6 is my radius. Okay. And then I'll work on simplifying this. So 45 over 360, I can see 5 is going to go into both of those because it ends with a 5 and a 0. So you'd want to reduce it, and ultimately it's going to reduce to 1/8 if you reduce it down all the way. And then this is going to be 12 pi over here. Okay. So when I multiply that together, running out of space here, this is going to be 12 pi over 8. Let's go ahead and reduce the 12/8 to 3 over 2. So 3 pi over 2. Okay, so it's this many centimeters, or if you wanted to do a decimal, you could take 3/2 times pi, or 1.5 times pi, and that would give you 4.71 roughly. Okay, so either one of those, just barely fit it in. Okay. Okay, so next up, let's find the area of the shaded region. So it works in a similar way to arc length. This is called a sector, the actual piece of pizza, the shaded piece there. So sector area is going to be part of the entire area of the circle. Okay, and area, remember, is going to be pi r squared, not 2 pi r. 2 pi r is for circumference. So for this piece, the part, it's still 45 out of the 360 degrees, and I'm just using pi r squared here instead of 2 pi r. Very similar to the previous problem, just the only thing that's changed is pi r squared instead of 2 pi r. Okay, so I would reduce this fraction in the same way as before, so this is going to reduce to 1/8. And then I'd have pi times 36, well, I'll write that as 36 pi. Okay, and then let's combine this. If I multiply, I'm going to get 36 pi over 8, and let's go ahead and reduce that. So let's see, 4 goes into 36 and into 8. That's going to reduce to 9 pi over 2. So you could leave it like this. It'd be that many square centimeters, or as a decimal, that'd be about 14.14 square centimeters. Okay, and that is the end of the warm-up, and I will see you next time.